macro level testing. Then of course, once you found that the system is not really working well, then you go into in detail testing, like okay, in detail testing. Then of course you go to each and every issue, like whether the content analysis is properly done. After analysis, all the the contents are really given the index terms. If the index terms are given, all of them are equal, equally, giving the importance for all the subjects, or some, there are missing terms which cannot really be given to indicate a particular subject, like that. We try to go into the details, like particular manner. Then of course, what I was discussing about it now, first of all, you have to what you really want to evaluate, decide. And then once you decide that, you design the evaluation system, how to really go about, you plan for that. Then you really try to see that and collect the data. Then you analyze the data, what you really gather, and try to interpret it, then come to some kind of findings that this is going well, this is not going well, this is the problem where the failures are occurring, etc. Then of course, what you really do is, now where the problems are really been coming up, you really suggest some remedial measures. That's what we really call it as therapeutic measures. If it is a problem in with the human beings, once you really do that diagnosis, blood test or some other test, etc., etc., then you say is a problem like this. Then doctor will really prescribe some kind of medicine or surgery, whatever it is. That's called therapeutic treatment. So you are trying to really make some suggestions. Then what you really do is, you really try to implement, use that particular prescription and the suggestions, you implement it. Once you implement it, whether the person is really doing well, like a doctor asking a patient, similarly the system is really working well, again you really go and make a test, like diagnostics again. Once again you do the diagnosis. Once you really again recheck it, I think it is working well, fine. Otherwise, again you really make some kind of recommendations, suggestions and prescriptions, and then you do some modifications until they come out. And that's how the system effectiveness always will be. Now what happens at regular intervals, you will be verifying, checking, and then assessing, and then evaluating how good it is going on. And then of course you really try to improve system, so that the indexing system will really work very well. It is as good as what we are doing is, we are comparing an indexing system with a human being. Like if a person is really sick or not doing well, you go to a pathological labs or doctor will say some tests, then you test, you found out the problem, doctor will prescribe some medicine, you use the medicine, then you will be all right, isn't it? So system also like that only. This is what exactly happened here. So in all these things, when you are evaluating this is how the process of evaluation of index system goes on. Then afterwards, what really happens is, there are some important criteria are there. There are some important factors are there. Now, those factors, those elements, those criteria, you try to check the index system whether it is working well or not. So the most important aspect criteria is the most important, the criteria what people really talk about is, now the recall and precision are the two important values. Recall means, in an indexing system we have got on a particular subject, we have 20 documents are there. When you went on to search the index database, whether all those 20 documents are coming out or not, are you able to really retrieve or not? If you are retrieving only 10, your efficiency is only 50%. If you are retrieving 15, your efficiency is 75%. Like, so this is what exactly very important. So the database, the indexing database has 20 documents on the subject what you are asking for. Whether when you go and make a search the index database, are you really getting all the 20 or not? That's one criteria. So for that, what you have really gone, the formula what you really said is that the number of relevant documents retrieved by the indexer divided by the total number of documents that are, the total number of relevant documents that are there in the database. Database, how many documents are there? Okay, now how many you retrieved? I retrieved only 18 out of 20. So 18 by 20 into 100, that is your percentage. That's what exactly we call recall value. Then the next one is what we really call it as precision value. These are the two. Precision means how accurately you are taking them out. When I go and then search for information, what normally happens is, in general, I get some documents, but all the documents are not relevant for me. That is exactly speaking about lack of accuracy. I should be able to get only those really relevant to me, no additional, no extra, no noise, no unnecessary document I should really retrieve. But it doesn't happen like that. When you go and search for that, some unnecessary documents also you retrieve it. That's what exactly the precision is missing. It's not there. So that is what you have to really do it like. So here in this, what you really do is the formula for this, the number of relevant documents retrieved against your search divided by the total number of documents retrieved by you. How many documents you retrieved, of which how many are relevant to you, how many are unnecessary have come. Okay, so this is what exactly the formula that indicates that. So if I have really retrieved, let me say 20 documents, out of which only 18 are relevant, 2 are unnecessarily there, I have retrieved it. 2 documents are not relevant for me, but then I retrieved it. So that is the case. What happens? I know the 18. Okay, 18 by 20 into 18 by 20 into sorry. Okay, no, this into 100. That's exactly what you can really say is. I think maybe about 80-85% of the recall value, the precision value is there for you. So this is how it normally happens. So how many total documents you retrieved and of which how many are relevant? I retrieved 20 documents of which only 8 are relevant. So 18 by 20 into 100. That's my formula. So in order to say that precision. So precision and recall values are, you have to understand this word, inversely proportion to each other. You follow me now? If you know indexer, or say for example the user also expects that both the precision value and index the recall value both must be high. 100% I want recall, 100% I want precision also. This does not happen in any indexing system, because now you will be learning only by way of doing some kind of index. You can really set some documents from database, you understand it like, okay, because in the short time probably it's difficult to really come back and then explain that. So if you really increase the precision, if you really want a high precision value and a high accurate value, okay, then the recall will go down. If you really wanted to have the recall value must be high, means the precision value will come down. This is what normally happens. This is a proven, tested, the kind of the formula. So therefore, people have come to say that the precision and recall values are inversely proportional to one another. Okay, if one grows, other naturally has to come down. It's a formula. So apart from that, there are other criteria also there. Now, how user friendly the indexing system is. When you went there to search for some information, how comfortable you as a user. Now, when you want to search for information, is the system is supporting you? Is the system is prompting you to identify a suitable term? Your system is really giving you within a short time. The time, how much time it is taking, how comfortable it is with you, response time, how much it is, the output, what you want, are you really able to really get it or not? Above all, one more important aspect is criteria is there. That is what exactly the coverage in the database. Like if your collection of the documents in that particular subject is wide, very comprehensive, very high, then of course you will get very good number of retrieval, like good number of items you can really retrieve, because your database is big, your collection is big. If your collection is small, expecting a good result is not possible. I told you initially, no, in a database system, in an information storage system, you have a storage is there, you have a database is there. The database represents the collection of your resources. Like if your resources are small, naturally your output also will be small. This nobody can talk. At the same time, if your collection is not only comprehensive, but are they really having the current documents, up-to-date information is there in your library, latest editions are there in the library. Only say, for example, 8 years back, 10 years back purchased books and the documents are only available, but we are not purchasing anything now, means your output will not be effective. There are so many other categories. So the coverage, maybe it's comprehensive, the coverage, whether it is up-to-date coverage is there, okay, or old collections are there. Old collections means you get only old data. I think that's not sufficient for you. So like that, what really happens is, now these are all the parameters, these are all the criteria. These are the issues you have to always verify when you are trying to check for whether the indexing system is working well or not. That's what normally we call it as evaluation of an indexing system. Like then we said another one was the failure analysis. Is nothing but when you really go and test it, you understand where the problem lies in the indexing system, whether it is in the indexing terms, whether it is in the filing mechanism, file organization, whether it is in the searching mechanism, whether you are key, constructing your search query to submit to the database, or whether where it is the problem is lying, you try to really identify. And then of course now you have to always see that the where the problems are coming, you have to really provide some remedial measures, some kind of there's some suggestions are we have to really make that, and then that's how it really can come up as a better indexing system. This is what we have really studied in our previous class. I think it took 20 minutes. That's all right, no problem. So then we have also studied three things also. Now it is the cost effective analysis, cost benefit analysis, okay, system effective analysis. I think these are all the two. Cost benefit means I told you it is what I really now if I really invest 1,000 rupees, so am I really getting at least 1,500 rupees worth benefit? Am I really getting? This is cost benefit. Am I really benefiting out of my investment? That's what exactly, okay, returns on investments, like ROI. That's a commercial way of looking into the industry. The other one is cost effective means I spent 1,000 rupees. If I really get the same service from outside world, outside agencies or institutions or organizations, now how much I have to really pay? If I am really doing the same service from my own organization, how much I really spent it? That means I spent 1,000 rupees. If I have to really pay to outside world, visit also, can I get really 1,000 rupees only or less than 1,000 rupees? If I can really get outside service from less than 1,000 rupees, there is no need. That means it's not cost effective. At least I should really get the benefit to the extent what I really invested. I invested 1,000 rupees. At least I should get 1,000 rupees worth value for me. Okay, like that you really look into it. And the other aspect is that when you really have to get the service from outside agencies or institutions and centers, what happens? They may or may not be able to provide you the service on time. So they take their own time. Yet you are making the money. But if the service is with you, probably within your organization, that you are saving your time. So you are in the next department is really providing service. Therefore, you don't need to really wait more time. So like that, there are so many issues are there. That's what we have really studied in the last class. Like today, now we will go on to the new unit. The new unit is what is the unit number 12, evaluation of ISR systems, experiments and case studies. So we have done evaluation already there. So now what we are going to do is there are think about 7 or 8 case studies and experiments on these indexing systems. Some people have really done earlier. So of all those things, something to be called as the Grainfield project 1 and project 2 are very popularly talked about. The experiments or the case studies on evaluation of indexing systems, evaluation of the information storage. They conducted some project, they conducted some survey, some study they really made. So what studies they have made and what are their findings? So this is what exactly we are really going to talk about. They conducted some experiments on, they conducted some surveys on the information storage and retrieval systems. Like so, then whether they are really what are their findings, what are their the kind of observations. If that is really been known to us, what really happened, we will be able to improve our indexing system. So the evaluation is primarily aimed at improving the performance of the system performance improve karna hai. That is what exactly the basic objective of our evaluation system of ISIR systems or indexing systems. The first most, as I just now told you, that the first most important the project that was Grainfield project 1. and Grainfield project 2. These two projects were done in UK, in Britain, like, okay. The person who has done this is called Clever Son. Clever Son is the person's name. He has really done this. The project, the first project, Grainfield project 1, the first project started in 57. They submitted the report in 1962. Okay. Now his name is C.W. Cleverson. Now what is the report is that the report on the testing and analysis of an investigation into the comparative efficiency of indexing system. So what the study was, the Cleverson, his name is C.W. Cleverson. C.W. Cleverson is from UK. He made a study of, what kind of study he made? He made a comparative study of some 4 indexing systems. He took 4 indexing systems. He really made which indexing system is working well. Okay, so first indexing system, what he has really done is, you can really see that. I will just show to you. So the first one, he took a subject catalog of a particular institution. In a subject catalog, I'm sure you know that you will give for each and every document some subject heading entries are given. I'm sure you know it, isn't it? In the catalog, you prepare author entry, title entry, this entry, that entry, followed by that. In the tracing section, normally you write that subject add entry headings, isn't it? So subject heading entries are taken maybe from CS list, maybe from the Library of Consultant list, maybe from the MESH medical subject list, and depending on your real requirements and subject field, you try to go to some subject headings list, and then you take some headings and give to the particular document, and you prepare some more additional entries. The entries are prepared on the subject heading. So the first one, what he has taken is alphabetical subject catalog of particular library using some subject heading entry, subject heading list. Then from that he prepared it, and that's one. Then he has also, what he has taken is, he has taken UDC, Universal Decimal Classification Scheme, and then using that he prepared the the alphabetical indexes, converting the UDC number into terms and words headings, like that is one indexing system using the chain indexing process. And in that UDC numbers are converted into subject headings, that is number is translated into words using the chain process. That is number 2. Number 3 is a catalog based special faced classification scheme, something like colon classification scheme. So another classification scheme he has taken. Then of course he has really converted the subject of the document is available in colon classification number or some faced classification scheme number, that he has really converted into the subject headings, like, or index entries, like. Then of course the 4th one is a uniterm indexing system. That means that is what uniterm indexing is, nothing but it's a post coordinate indexing system. Now in this we are, instead of combining all the concept terms, what you really do is, now if a particular document is dealing with 4 concept terms, you prepare 4 concept terms on that, and each and every concept term, that particular document number you post and then file it there. People will come and use it, like that. So one is a post coordinate system he has used. The other one he has used a faced classification scheme he has used. The other one he has used, what you can really say is UDC classification scheme he has used. The 4th one he has used a normal library catalog, subject catalog he has used, like, okay. So subject headings. So like that, these are all are 4 kinds of indexing systems only, 4 kinds of indexing languages only. You follow me now? So they really, whether the normal general library catalog having subject heading entries is doing well, whether a kind of what you can really say UDC classification scheme used, okay, from their class number, when you really derive the subject heading entries and keep it in the index file, is doing very well. Or if it is a kind of what you can really say is it is a faced classification scheme like a colon classification, from there when you really draw the subject headings and use for the database, is it really working well? Or the 4th one is now the uniterm indexing system. Of all these things, which one is really doing well? This is the first important the kind of experiment the first important kind of, we can also call it as a case study. It's a kind of first important kind of, evaluative study, a survey that was really be done by, it's also popularly called as Grainfield Survey. And Cleverson was the name of the, the investigator. And the findings, what they really want to really come out and say, the observations are that all the four indexing systems, they were operating with an effectiveness in between 60 to 90%. Okay, the efficiency, the effectiveness of the all the four schemes are in between 60 to 90%. Okay, then what they really came out and say that that is that 60 to 90% of the recall ratio is there, whereas when you use uniterm indexing system, the recall ratio was 82%, not too high, not too less. It's certainly it is fairly good. Okay, the highest was 90%, the lowest was 60 of all these. But when you use the uniterm indexing, that's, we suppose that it is going to be the best scheme, we normally call it. It has got 82% of the recall value. There are 2-3 things you are talking: recall and precision. When you really want to get back what is there in the store, are you really getting all of them? So 82% efficiency is only there in uniterm indexing system. Like, then of course, if it is alphabetical indexes of the library catalogs like thing, it is 80.5%. When it is coming to UDC, it is only 70%. So UDC class numbers containing documents, when you really convert them into alphabetical subject index entries, and when you really use them as index file and search for information, its efficiency is only 76. So UDC scheme is 76 only as far as that is concerned. So like that, what they really want to say is, but comparatively, of all the classification schemes, the facet classification is supposed to be the best classification scheme. Because you can combine any facet, for this to that to this, etc., can be really combined. Like, any number can be added to any other number. That kind of the facility will be there in facet classification. That means supposed to be the best kind of indexing system. But supposed to be the best kind of indexing system, what you are really using, calling the facet classification scheme, it has only 74% of recall values there. 74% is much lower than unitary index system. It is much lower than what you can really say is UDC also. UDC is giving 76, it is giving only 74. So like that, now in the facet classification scheme based indexes, when I'm talking index, means index terms are used, not index numbers. So facet classification scheme will give you the index number for the document. From the numbers, when you derive the subject headings, those headings when you use in the index file, and that you when you really go and evaluate it, these kind of index entries prepared with the facet classification scheme is the least one of all the schemes. That is the lowest. That's another finding. Then of course, what they really found is that there is no significant difference between in the case of retrieving documents. Okay, so when you retrieve the document, the retrieval is almost efficiency is more or less same. Like when you went on whether this kind of index file or that kind of index file, retrieval is, I think, more or less same. But then of course, now the increased time spent on indexing improved chance of recall. Fine. Now at the time of indexing, what the observation is that at the time of indexing, if you can take more time, calmly, quietly, composedly, if you can really think for a while very clearly and give an index entry, such kind of thing. That means in indexing, if you take more time to give index entries, such kind of index system is working very well. It's real. The recall is more in such kind of things. Like the more the indexer is experienced, the efficiency is also going to be, the retrieval efficiency is more. If the indexer is a new person like you and me, you are a BLSc or MLS student or joining in the indexing work, when you are doing, or 10 years old, another fellow who is doing indexing, the 10 years old experienced person is doing a better job. And if a 10 years person has really done the indexing, the recall value is great in that, very high. Like, so these kind of findings are there. Okay, this is what you can really say as far as your Grainfield project indexing, the kind of. Now coming back to the they really said what went wrong there? What are the failure analysis? Kahan par system has failed? Where the system has failed? Okay, then what they really said is now when people, I come to the library and ask the information. I want to know something like that, the food grain production in India and then some poverty, etc. I just wanted to say how to know something like that. Then, when I am expressing my requirement, I as a user may or may not be able to express in right terms in a correct way. Okay, and when you are expressing to, or I am expressing to in a librarian or indexer may or may not be able to catch that concept correctly. So that kind of things, what you can really say is there are then of course the indexing failures can be now insufficient indexing, because document deals with 4 concepts. Now, but then you have really given index entries only for 3 concepts, so that's insufficient. Okay, now then the indexing failures are the 60%. The what they really, then of course now too detailed indexing is also giving a wrong because we are unable to really get the exact information. Too narrow, too detailed, omission of some other concepts. Okay, incomplete entries, careless indexing. Yeah, just casually if you can index something, I think that's really helps. These kind of things are 60%. The problem, what you say, the failure analysis is more at indexing failures, and followed by that the searching failures. When you really go and combine in the concepts and searching the index file there. So the searching concepts is number 2. Number 1 is what you can really say is indexing failures. These are the the what you say, these are the failure analysis. Once you really conducted the survey, once you conducted the experiment, once you conducted the assessment and evaluation of the indexing system, where it went wrong, where it went, that's failure analysis. So in the failure analysis, they really come out that if the failures are there, the failures in systems are nothing but 60% of the failures are only indexing failures. You did not index properly. That's a problem. So that is the most important thing. Then of course the next thing is you did not construct the search query. Okay, search statement, you did not do it. Therefore, so these are all 2 important, the failure, the reasons. Okay, the reasons of failure of indexing system, there are 2 are these. Of course, there are also system failures are also there, like your indexing system was not good, your classification scheme was not good, your headings were not good. So like that. So this is what the project number 1. Project number 2 is Grainfield project 2. Okay, in this Grainfield project 2, this study was made.
Sir, excuse me, sir.
Yeah.
Sir, page number, sir, please.
You want page number? It is 216, 217.
Okay, sir. Thank you, sir.
215 also, 215 onwards, 215. Okay. So the second project, what you really call is now this is Grainfield project 2 that was really been done in 1966. The first one is also, I think, Grainfield project only, but it was called as Grainfield project 1. It was completed in 1962. This is in 1966 after 4 years. Okay, at least you try to really remember that. So what they have done is they have tried to understand the components of indexing languages. Now here the question is indexing language components, how effective they are. So indexing language in that, of course, in terms of recall and precision only, they have really verified. And while doing so, what they have really done is they have taken one broad subject called now aerodynamics, and then of course slightly narrow specific subject called aircraft structures they have really taken. So aerodynamics is somewhat a bigger subject. Aircraft structure is somewhat a small subject. Both are of course engineering subjects only, and they really made this study. And they have taken a collection of 1,400 documents, articles, and reports they have really taken. They made a study, and then in the study, what they have really done is they have grouped something to be called as synonyms in alphabetical index So all the synonymous terms really reflecting a particular concept, they are really put at one place. And so people can really search on the actual keyword or its synonyms also. That's number one. Then the second one, they also grouped all the word forms in alphabetical index. Like, say for example, I don't know, compute, that the truncation, COMPUT, computer, computers, computerized, computerization, and all these things are extension. You stop it at COMPUT only and expect that any other extensions of that, any other derivative words from those root, all this can be really surveyed. That's one thing. Then of course, and another thing what they also done is, there is a broader term like physics, narrow term like optics and light. They also combined them all, so people can really search and find anything like that. They grouped it. Then of course there is a pre-coordination, the schedules, like some of the related terms, etc. They are really grouped and put one thing. So this kind of things they really done, and then they make a study on that. Then what they really, the findings of the study, what they really could come out is, their main conclusions was that now, by shifting from one indexing language using uniterms to one using concept phrases, normalized, recall fell from 65 to 45%. So if you can shift the uniterms into normal subject headings, indexes, like, no, they made like the study, it's only indexing language study only. So they were initially using uniterm indexes that were really been converted into subject headings. So you combining all of them. If that kind of conversion from the uniterm indexing into subject headings is really done, the recall value has come down from 65% to 45%. 20% has really come down. That means what really telling it? So if you can really retain the uniterm indexing system, your recall value is high, not with the subject heading entries. That's the finding from here. Then of course, a single term language with its normalized recall fell from 65 to 61%. Like, okay, now if it is one single particular term and if it is really been expanded, like, then of course, expanded means you have seen now computer, computerization, computerized, so when this kind of actions are really been permitted, now what happened? The recall value also has come down. You have to give the specific term only, isn't it? Computerized indexing. So if you say computerization, computerization of indexing system is something different. Therefore, you get unnecessary things also. So your recall value is also going down. Expansion in the concept language, now it is normal recall from 45 to 75%. So if you really expand the concepts and the concept language, you really wanted to elaborately really do it. So they are good. Thesaurus relations were introduced into control terms, then normalized recall fell from 62. So like that, if you are really adding some more and things, your recall value is really coming. So the control terms have less recall value than the natural. The most important finding of the second Grainfield project 2 is that if you use controlled indexing system, if you also used the natural language indexing system and natural words only, say for example, optics is a controlled word, light is the normal word, the subject light, isn't it? Okay, bird is let me say is a general term, natural language word. Now for birds you say aves, aves. Aves is the scientific term. When you use control terms, your indexing performance has come down. If you use the natural language words, indexing value has really gone up. Okay, performance value. This is what exactly they really say. Natural language indexing has better recall and precision value. Natural, so the findings are that natural language has got big people, because many will be really using only natural language. So natural language indexing systems, instead of controlled vocabulary terms, you use an indexing system. Natural language indexing system has got a better recall and precision value. This is the finding as far as your the what you really call the Grainfield project number 2 is concerned. Then of course I will tell you one more project towards what we say at page number 221. FAIRS, that is exactly United States Federal Aviation Agency Indexing System. That's what exactly people call FAIRS. Now, a person who is, his name is D.E. Berninger and his associates, they have evaluated the operational system of FAIRS, operational system, how it is being functioning. That's what exactly operational system of index system, US Federal Aviation Agency system, they have really done it. And in that, it's an aviation engineering system. They have made a study on these technical reports are there. And these technical reports are really been indexed using some thesaurus index terms, maybe thesaurus of engineering and scientific terms, or maybe they must be having their own special thesaurus on aerodynamics or aircraft engineering, etc., etc. I think they have really used it. Now the feedback on that, what we really could get is that now in this they have used generic terms, general terms, and for the along with generic terms, they also use some specific terms also. So in this generic terms, and then also some specific terms also they really used. So in one case, they have used generic term one set with narrow terms, specific things also. So generic term is a broad heading. Understand? Generic is a broad heading. Something like pet animals. And then the specific term is a cat. Isn't it? Cat is specific in the general pet animals, like, isn't it? So pet animals is part of mammalia group. In the mammalia group, there are other animals and pet animals also will be there, isn't it? So like that, the generic group is generic terms are nothing but these are broad terms, and then followed by specific terms also. Like that, in the first group, what they will say, generic term 1 and specific terms S1, S2 are they have given, like. So like that is gender 2, and then in the case S1, S something like that. So generic term and followed by the narrow terms also they have really given. When they really conducted the set strategy, strategy A included originally chosen search terms, and search strategy B here we have got here. Now here what say A is in the next page. Pressure ratio for A is 59%. Now what is A? Now search strategy A include only originally chosen search terms only. Now these standard terms are only taken into consideration. Both generic and specific terms are there. When you really make a search, performance was your pressure value was 59%. Okay. When in the B category, it is in the strategy eliminated specific terms are not there. Only generic terms are there. In the B category, we have not given specific words. Only B we have given only the general terms only. The pressure value is 35. So when you have generic terms are there, pressure value is very low. Try to understand. When you give a broad heading, the pressure value is low, because there may be people searching on the specific headings also. Specific terms. That's what exactly. Okay. Then of course, when for the same generic terms you are given, your pressure is 35%, but your recall is more. Understand now here? I told you, in the case of B, you have used only generic terms. In the case of A, you have used generic terms or also specific terms also used. When you use both of them, your pressure value is 59. When you used only generic terms, 35 only pressure. But recall value has come down for when you used both generic and specific terms. Recall value is 22 only, 22% only. But when you use generic terms, your recall value is 73%. So this is what normally I told you. Both recall and pressure values are inversely proportional to one another. This is also proven. So like that, they made a study and then try to find out. Now in the search C strategy, what they included is generic terms G1, G2, G3 and eliminated non-pertinent specific terms, which are not really clear. They are really eliminated. They made a search like this was slightly, the pressure is low, but at the same time, recall is also more or less okay. But like that. In the last category, now D category, what they have done is the coordinated generic terms with selected specific terms. So they combine like G1 with any terms specific to G2, G3, G2 with any terms. So any term combined with anything, I think they really allowed it, so that what really happened, the pressure value also 45 generic terms, but recall value has also come. So this is what exactly they study as far as what we really called as FAIRS is what nothing but it's a United States, that is American Federal Aviation Agency's indexing system done by Berninger, and he really come to see that if I really use a broader heading and a generic a specific heading, only broader headings, only specific headings, combine both of them and combine all of them, then how the precision and recall values are really there. This is what exactly a study they have really done. There are other things are also there which we will try to really look into a little later. And one more one I just wanted to just put before you, and before what your time factor is with me. Therefore, the other one what you really I want the evaluation of an expert system based. It's an expert system based interface to Medline and Can Search. Medline is medical, okay, medical literature online, medical literature analysis and retrieval online. That is Medline. Medline database is a medical database. Medline database is really it's a database created by National Library of Medicine from America. Okay, NLM. It's normally called as National Library of Medicine. Okay, NLM of US, like, okay. So National Library of Medicine was one of the foremost now the medical institutions which has really come out with the computerized indexes. Now of course it has also come out with the kind of a thesaurus called mesh is what exactly? Medical subject headings, like. So this is one of the foremost indexing schemes. Medline, Medlors is medical, okay, literature analysis and retrieval system is Medlors. So Medlors database is available online called Medline. Medline and Medlors are part of NLM. NLM is the National Library of Medicine of America, like. So they have a database. Now in that, now what they are doing is Medline database or Medlors database, whatever you really call. In that one specific database is called something like what you can really say is Can Search. Can Search is nothing but cancer literature search and retrieval, like. It is we exclusively for the cancer related the literature. They have started in the Medline. One specific database is there, a small database within a bigger database. Bigger database is Medline database or Medlors database. In the Medlors, Can Search is one is there. No, Toxi Search, that is about the poisons, toxins. Okay, like that they have got different specific database are there within the Medline or Medlors database, like. So the Can Search, it's a kind of what they said, it's an expert system based user interface. What they have really studied in this is it's an expert system based user interface, like. What is expert system? I think you also have got maybe 13th 14th unit you may be having something about artificial intelligence and expert systems. One chapter is there. We will discuss in detail there, but at least I will try to give you some basic information on what is this expert system, like. Now what happens now let me say you have a medical expert system is there. Okay, understand? Just imagine there is one system called medical expert system. What exactly it means? In the medicine, the medical practitioners, the doctors, and their experiences are fully recorded and created a database. We created a database of n number of doctors, large number of doctors who are practicing the medicine. We have taken their experiences, like, say, for example, what exactly I really want to say is now I go to a doctor. Okay, now there is a stomach problem is there for me. Okay, then I go to a doctor. The doctor, I have a problem in my stomach, the stomach is aching, there is a pain is coming in my stomach. Then he will really ask you which side of the stomach you are getting pain. This side. How long you are getting the pain? Oh, this is for 2 months. So do you have any burning in that? Do you have a pain outside pain or inside pain or burning pain or pinching pain? How long you have got this? Okay, so like that, then he will also ask you the related questions. Do you have also any kind of blood motions? Do you have any kind of this etc.? He will really try to assess, like, then he will assess and he will assess and assess and assess. He will make a question. He will be questioning the patient. Do you have this? Do you have that? How long it is there? What is really happening? What medicine you are taking? How it is really working? No, do you have any this kind of things are there? Do you have any fatigueness is there? Do you have any blood motions are coming up? And do you have pain here, pain there, etc., etc.? Based on all these things, your doctor will come to a conclusion that now in your intestine there is a kind of what you can really say small ulcer is there. There's an ulceration is there in your intestine, small intestine, something like that. So it probably it may get cured with these tablets. You use it. Otherwise, you may have to come for surgery and will remove it. This is what your doctor will tell you. Follow me now? Understood? So now this kind of, when a problem with a patient goes with a problem like this, now how the doctor will be eliciting, getting the information from the patient in order to come to a conclusion and decide that you have this problem, you have that problem. So they are going to diagnose, So this is what exactly we say. The expert knowledge of the doctors are programmed and recorded and kept there. Like a doctor is asking you, when you enter into expert system, it will ask you, you just say that what it asks you, what's the problem? You say this is this. So it also again asks you how long it is there for this one. So you have any pain here, etc. Do you have any other side effects are like this, anything, etc. It will be asking you. It's a kind of what you can really say is now a conversation between you and the kind of software medical database is there. The expert knowledge database is there. It is really asking you. There is no need to go for a doctor now. The medical expert system will also really come to a conclusion like expert doctor and give you the prescription also. So this is what exactly we call a medical expert system. Okay. So this is an expert system and it is user interface. Now you are really going, there is no kind of, the physical doctor is available to you. There is no human being as a doctor. There's a kind of, the kind of a programmed knowledge is there. A packaged knowledge is there. And you go and ask your computer system, now this is the problem. Then it will ask you, what is this? Now, how long it is there? Are you having this? Are you having this? How long you are having it? Then it will say, yeah, you have this problem. Come on, this treatment, you can go ahead. So this is what exactly, instead of going to a doctor, like an expert doctor, it will also diagnose your problem and also give a prescription to you. That's what exactly medical system. So it's a kind of computer system. There is no human being is involved. There is no human doctor is involved. But only thing is the human doctor's expertise is really been kept in the database. So that's what really works like. So we can have a catalog database like, when you are going to catalog a book having 4 authors, it will really tell you how many authors are there for a book. There are 4 authors. According to your AACR 2 rule, when there are more than 3 authors are there, now you have a rule base is there. Now the rule will be there in the database. It tells you now when there are 4 authors are there, make main entry on the title of the document and prepare the add entry for the first author. This is your rule. So the rules and the knowledge is really been packaged and kept there. This is what you really call as expert systems like. So it's a medical expert system. So then like that now, this expert system, they really wanted to find out how good it is, when it is a user interface is there. That means a user is interacting with the computer system. A user is interacting with the expert system. Expert system is the expert knowledge of the practitioners in the field is programmed and kept in the computer. That is your expert system. It's an artificial intelligence because there is no human being. The human being knowledge is elicited, obtained, and then recorded and kept there. Now there is no human being. Okay, as far as knowledge is, first time you got from the human beings only. You programmed and kept there. You packaged it there. And you are going there and asking for information. It will really give you the information like. Okay, so that way, now there is a kind of, it's a computerized system. It's a computerized expert system. It's a computerized system which is having artificial intelligence. The intelligence is artificial. What do you mean by that? The the intelligence as good as the human doctor intelligence is really been kept in the computer. Computer is a machine, artificial, isn't it? Not human being, isn't it? So therefore we call artificial intelligence. The intelligence of the human beings is kept and recorded and kept into the computer. Now you are calling it as artificial intelligence. So it is as good as like a human intelligence only. Okay, it is there and there is no human being in that. So then how you really do it like, so it really wanted to find out now if there is a kind of expert system is there, and with the expert system based, if you are a user and going and interacting with the expert based in the indexing system or expert based database and trying to get your information, how nice you are really going to get it. So this, it was really been a study was done by the cancers is only in the specific field called cancer treatment. The malignant tumors we normally call malignant tumors, like, okay. So that's something like that. When you really give a keyword called breast, it understands that it is a breast cancer only because it's a cancer database. So like that, how the computer is really going to, when you give a keyword, it will really convert using the keywords into the suitable controlled vocabulary thesaurus terms, like what this term can be in mesh thesaurus. Okay, it will, your word is really been converted automatically by the computer into that way, like, okay. Then of course it automatically arranges your own concept words hierarchically in that, when you really try to put a question there. Then when you are going to select some entry settings, etc., because in artificial intelligence is already there, it shows before you a menu. This is what really, when you give a word, it will also open before you so many other alternative, the names, maybe a broader concept term, maybe the narrower concept term, etc., also will be shown to you. So that what really happens, it facilitate you to identify a suitable heading, like this kind of things also will be really there. Then of course what it done is, in the artificial intelligence system or in the expert system, what happens, the if and then. If means a situation, if given a kind of the pain on this left part or a right part and so on so the stomach, then of course this kind of the bonding reaction is really there. If and then kind of the study, it will automatically makes analysis. And then when you really use something like in your search query, let me say the use of fluorouracil treatment of breast cancer. That's what exactly you want to say. Fluorouracil is a kind of maybe a chemical compound. If you really wanted to use that for the breast cancer treatment, then of course it will really put before you now cancer as a a particular site in the body, and it's a therapy. Then all the things will be really shown to you relating to that, other alternative, other narrow or other broader headings, etc. terms will really breast from controlled vocabulary displayed in hierarchical form. And then of course chemotherapy is a kind of therapy. Chemotherapy is one of the therapy for the cancer. So like that, all things will be really displayed for you. So that what really happen is, you will really be able to identify a better index term, because computer is giving you the prompting. So when you put a such query like that, are you really thinking about this, etc.? You see, this is a broader one, this is a narrower one. What exactly you really want? It's putting before you all of them. So that what really happens, now the system has user interface to direct or guide the in arriving at an appropriate index entry. So the computer itself is prompting you, guiding you, giving clues to you. For if this is a subject, you identify this term. So like that, it will really go you. So then when this kind of the studies are made, the findings of the study were that the novice end users could use can search to specify the subject of a query concerning cancer therapy. So even the new people coming into this kind of the expert system based inquiry of the database also, they can do very well. There's no problem on that. The cancer search database would be able to generate legal medical search statements also. So all the appropriate headings will automatically create and do it. Like relevant documents could be retrieved from the Medline database. I told you, medical literature online, when it is available on online, that particular Medlot's database, it's called Medline database. Like, so cancers would be as effective as a human intermediary or search analyst. If some other expert fellow is with you in searching and finding, how you really feel comfortable if with this artificial intelligence or the expert system also, you will be also benefited by that. This is what exactly the study findings. This is cancer Can search is cancer, database searching like. Okay, cancer. It is part of the Medline or Medlor's database of NLM like. So this study was really done. That means to say that if we have the artificial intelligence based, expert based, okay, computerized indexing systems are there, people can easily try to get what they really want from the database without much inconvenience of, there is in some cases recall value is more, in some cases precision value is more, recall is less, precision is less. So these kind of problems can comfortably be overcome if you have got a computerized the system like. Okay, then of course there is one more system is there. I think I will precisely try to do it like the evaluation of the effectiveness of a user interface. The earlier one also user interface only. User interface means user interacting with the computer. User interface is user interacting with the computer. How computer will really respond to you. So another thing what they have really done is they have used something to be called as a CONIT, CONIT, which is a common command language. CONIT is a common command language. Means what? Here we have to understand there are three things are there. So this is also a computerized system. Okay, now this is also a computerized database you are trying to interact your user. But what really happens, let me say, in each and every subject, we have multiple databases are there. Okay, you take social sciences, you take medicine, you take agriculture, you take engineering, etc., etc. There are so many databases are available in each and every subject. So if a user comes and asks for some information, searching only one database will not be able to provide satisfaction or justification to the the query or to the kind of the information. If you can really provide only from one database, it is not exhaustive. So because there are other databases are also there. Let me say in the case of library science, you have library and information science abstracts are there. You have library literature is an indexing publication is there. You have Indian library science abstracts are there. You have information science abstracts are there. You have like that library and information science and technology abstracts also. LISA and LIST also there, LIST. Okay, LISA is there, LIST also there, ILSA also there, of course library literature also there. So like that there are so many indexing and abstracting services are there. So if you can really search on multiple databases, what really happens, you will get a better retrieval. So you cannot really stop searching only one database and then provide to the user. It's not really going to help much the user like in the present context. Why? Because there are many databases are there. At least you should have a few databases you should really able to search it like. Okay, otherwise you get only small number of output, which is not really complete, not exhaustive like. Okay, so therefore at this point, another important thing what you have to understand is every database provider, every database vendor, okay, or every publisher of the database, they not only put the records and the data about the kind of subject information, whatever you really call, but they also really write a software program in that. The software program is how to search and how to really retrieve information also will be there. That will be specific and special to each and every database. Every database, the arrangement of the records in that, and then how to retrieve, search and retrieve. Okay, and I think they are all unique, special, separate for each and every database. Imagine you have, say for example, 4 databases are with you in medicine or medical subject or something like that. So 4 databases, searching mechanism, search style is different, not same. Every database has its own different style of searching like. So what happens if an indexer, or sorry, if a librarian or a user goes to a particular database and trying to search for information, what really happens is you have to use the the style of searching that is already prescribed for that particular database. Okay. Similarly, now when you are using another database, you have to use their own database style to search for information like. Okay. Now in this case, what happens? A user or the librarian has to try to learn more number of search, the methods that are used with different databases, like, which is really going to create a lot of problem for all of us. So to overcome that, what they said is, now they said there can be one common command language, no common query language. You should really ask a question. It should be, applicable to all databases. So once you prepared a search query, means the same search query can be really applied or, used with many other databases. You don't need to again reformulate and reframe your own search query when you are searching another database. Normally it happens like that. So for each and every database has a different style of, searching like that. Now in these days, what really happened is, now we have got an intermediary in between. What we can really say is a common command language is there. That means even you really give an index, a keyword to search for information, the system automatically will convert it into the database style of word only, how it is really going to serve. So like that, what happened, the Connect is really using, I think there are three databases are really used in this, three different databases. One is Medline database, other one is SDC Orbit database, and the last one is Dialog database. Dialog, SDC Orbit, Medline, Dialog, and SDC. There are three databases are used. Now, then of course, when this Connect is really connecting all these three database systems, you will be able to really search, all the three databases using one single search query only. You don't need to really have it like. So the requests are, generally translated by the system itself, computer itself, into the, the computer, the style of, your words like. So the user, whatever the words you give, the words are really converted into the style of the form of the words that are used in the index of the particular database like. So for all these three databases, I think the appropriate comments it will take from the user and converts into like that like. So this is what exactly the common command, the things like. Now there are some the scheme. What really happens is, now it has really taken different types of users, like some of the expert doctors, some of the, what are non-academic university staff, some are professors, some are the postdoctoral people, 6 graduate students, etc. Like there are, I think, 16 people it has really identified and then make a study. And then what happened, the first important aspect is when they are searching on this, a database using this common command language. Okay, common language. You use any language, it will get converted into the database language. Okay. So none of them are having any previous experience. All of these people searching with the Connect, and what really happened, they all performed searches on 20 different topics of the Connect with no assistance from the index or no assistance from the library. Nobody have helped you. You are asked to go and then search information like. Okay. So then now what the results were that Connect and sometimes the human expert were clearly superior. Now, if a human expert is going on searching for database, what could the results? If a novice, a new fellow is going and searching with the Connect, that's what exactly called Connect. I think it's more or less same. Sometimes, experts are really having a little more edge. Sometimes you Connect, you without experience also, it's really having a matter edge like. The effectiveness is more or less same like. That is, recall and precision ratios are more or less same. Whether a subject expert is really going and searching, a previous having knowledge fellow, or a new fellow is going and searching, also more or less same like. Okay. The Connect achieved a higher level, higher online recall at the expense of longer search sessions. This is what they really found out. If the people can stay on the computer for longer hour and searching, the recall is more. Instantly, just you give a search and then ask for, I think the results are not going to be too many. as far as quality is concerned. Okay, and then in terms of search time, which has a direct bearing on the cost of the search. This is true, because if now things have changed. In the past it was not like that. So how much the online database you are searching, you have to pay. If you are really been 5 minutes are there, maybe you have to pay about $10. If it is a half an hour is there, I think you are paying more money. That was the situation earlier. So if you really stay on the computer for longer hour, your output is more. You are going to get better recall value, better precision also. But no, when you are staying on the computer for longer hour, what happens? You have to pay more money. That's another problem is here. So the number of relevant records found and viewed online was much higher for the user cognitive session than for the human expert session. So what they really want to say is, the more relevant records are really been found on online retrieval from the cognitive than a subject expert and expert fellow who is going and searching from information from other database is not really that good. So like that, these are some of the important findings. These are all nothing but these are the case studies. These are all the experiments. Cognitive is common command language. Common command language means whether you really apply any of these. I said orbit, SDC orbit, dialogue, as well as the third database, dialogue, SDC orbit, and byteline. So in all these three databases, now they are integrated. Now when you give a question from anything suitable to that particular database, it is getting converted. Okay, so you are facilitated. So Quant is a common language. You use any language that gets transferred into the suitable index term language used in the database. That's how retrieval really going to affect. This is what these are all the studies as far as you are, what you really call what is that exactly? The experiments or the surveys or the evaluation studies made on measuring the effectiveness of the indexing systems. So that's what we have really finished. Now I think we will really move on to the next unit. Probably we took a little more time. Anyway, we will talk about the next unit is the unit number 13. And for you people, I think it is page number 234 onwards. Okay, 235. Okay. Now in this, the topic is information access, online and CD-ROM databases. Okay, online and offline databases. CD-ROM is in offline. So some are you are directly getting information from the computer online only. Online means now what exactly you mean? Through the internet. Okay, internet based okay. Now the same database, if it is available on CD-ROM, you must be really knowing CD-ROM, isn't it? So CD-ROM, okay. Now that what you really say, CD-ROM is with you physically in your hand, isn't it? So CD-ROM database are with you, and you can really use it okay. So like that. Now there are CD-ROM, the same database is available online. Okay, then same database available on CD also. 1 second, you all know CD or CD-ROM or not? Please tell me, anybody. Do you know CD-ROM or not? I want answer from you. Unmute and tell me.
We know, sir. Compact discs.
You don't know? 1 second.
You know, sir. You know, sir.
You know it. All or no? This is my CD-ROM box. Actually, it's a DVD. Okay. Can you see?
Oh, number of cities.
This is my. Are you able to see now?
Yes, sir.
Yes, sir.
Yes, sir.
This is a DVD-R. Now, okay. So this is a writable and rewritable. Okay, normally the CDs are not only readable. Okay, and we have got so many other kinds of CDs are I'll show you CD. It's a CD. It's a CD, and it has e-journals to e-books. There is a kind of document in this, like. So on this one side, only this printed thing is there. On the back side, you can really find that the circular pits will be there on which your data is stored. So one side only. This is what exactly silicon based like. Okay. So using the computer, there are pits are really been made in that. So normally what we say when you are trying to record or write anything on that, people call it as burning the CD. With that laser light, the computer automatically it creates the text is really been stored in this. This is called this is a CD. The general CD is like this. Okay. So CD capacity is very small. Anyway, DVD is the advanced digital video disc, like normally we call. So several CDs data will be there on this is a DVD.
4 GB. 4
Okay.
GB.
Yeah, I think I'll tell you once again now how much capacity. I think when you say how much they said here, now it is really going to have I think 4.7 GB, and there are 6 GB and more GB. Okay, that kind of capacity is in this. So gigabytes. Okay, up to 6 DVD. This is a DVD. DVD is having 6 I think gigabytes data is there. Okay, anyway, this is what I just wanted to show you. What is CD? CD will be like this. This is a DVD anyway. This is CD. Both are same. Everything is same. Everything is same, isn't it? So, but only thing is the file capacity is more. We call it digital video disc, digital versatile disc. Okay, you can have video, etc. Video normally takes more space than text. Therefore, we have come with that digital versatile disc, digital video disc. Otherwise, this is only CD, compact disc read-only memory. Normally, it's read-only, and I think rewritable CDs have come. That's a new development in the CDs. Earlier, only once data is stored in this, you cannot erase it. You cannot rewrite on that. If it is a kind of tape or a magnetic tape, you can erase that and you can write it, like pen drives or floppy disks, etc., etc. That's possible. But in this, it's not possible. But we have also got some new kind of CDs and DVDs have come, where you can also write and rewrite. Erase that and you can write it. So that kind of things also, it's a new development also have really come. This is what we say, these are the CDs and DVDs. Okay. Now anyway, we are going to talk about that a little later. Right. This is from here. Okay. This is from here. Just 1 second, I'll just tell you. So these days, you get on the DVDs. So many other things are coming. Like this is a okay 4.7 DVD. Okay, we have got some songs. We have got some pictures, motion pictures, movies, etc. You can really see in this. So this is what. Okay, cherish the occasions of life, something like that. This is what really happens. Anyway, we will stop it here. So these are all of my DVDs. So many like that. You can use them. This is Sony DVD. DVD it's 4.7 GB. That's the capacity. Okay. 120 minutes of play can be really. That means almost 102 hours play can be released. 2 hours movie can come in TV. Okay. Anyway, now let's go into our unit. We are really good. So when I say CD means physically in our hand here. We call them as the CDs and DVDs. Your topic is in online and CD-ROM databases. Okay, the databases can be available on the internet, which you can search and retrieve online through the computer using the network technologies. Now the other one is the same database can be stored in this CD-ROM or DVD also, and you can access. So CD-ROM DVD is with you physically like a book in your hand, but of course you have to again use for the computer only. That's what exactly the difference. Otherwise nothing. CD-ROM is a kind of what we can really say. CD-ROM databases we call it as offline databases. Now when you are searching online using internet and network technologies and all those things, you call them as online. Okay, that's what exactly you really going to do. So this unit we will try to cover, I think now. So most of the today's world is shifting from traditional print databases to the digital resources. Digital resources means electronic resources. Electronic resources can be directly you can access online. You can also have it physically in your hand like CD-ROMs or tapes or DVDs, etc., etc. That's what is the point. So traditional methods of information, processing and information, is really going to be a delay in communications. Like if it is available in digital mode, sending it to people and then using it is very easy. Okay, therefore that. Then of course the information people what really want is, I want information, current information. I want comprehensive information. I want cost-effective information. This is the demand from the people. Like there are people called as 3 C's. 3C. The first C is I want current information, up-to-date information. I really want, not old. Okay. Then of course I want comprehensive information. That means everything I really want. Number 3 is that I want cost-effective information. That means now when I'm paying this much of money, I should really get to the value of that particular. So all these things are possible only with the print. You cannot revise the document regularly. If you want to really go for book publishing, it takes a lot of time. If the information is available in a digital form, today itself 120 times you can revise it. Nobody can ask you, isn't it? So if it is in the print form, you can't print it again and again. It takes a lot of time. So therefore, it must be current, up to date. It must be cost effective. It must be comprehensive. A lot of information, everything should be available to you. This is what exactly demand of the people. All this is really possible only with the what you can call is the information communication technologies. ICTs are really supporting that. so that we are really going to see a lot of electronic database are really coming up. The database can be in CD-ROM form. The database can be in online also. Okay, so that's what exactly we are really going to call it. Now then, of course, in these days, another important what happening is the earlier the abstracting indexing publications like chemical abstracts, biological abstracts, current contents, these that all those things in the beginning they used to be in the print mode. Now they have been now converted to digital. Now they are coming as either online or offline. You can really have it like, okay, that's what is really going on in the current time, because people want instant information. I want information just now. I don't want to come to your library, but I want information now. Yes, people are getting it, isn't it? So that's now just possible only because of information communication technologies, and particularly when the information is available in digital form, that is possible. Transferring, sending by email, sending by some other attachment, etc. This way, that way, you can really scan it and then you send it. So you can do so many things, isn't it? That's because it's a digital form, it's an electronic form. That's possible. Like, okay. So what is a database? You're talking about online databases or offline databases. Like, what is a database? A database is accumulation of interrelated data or information. Some interrelated data or information is really been some records or really interrelated records are really kept and call it as a file or a database. Like, okay, so database is an accumulation of interrelated data or information. It is organized into machine readable records, so that is in a machine readable, computer readable records. And then of course what you can really say, it's easy for easy retrieval and processing. So database will help you easy retrieval and easy processing, and you need a computer, and they are really going to have some records or a set of the interrelated records, or the files are really been stored in that. That's really going to be called as a database. Like, it's a computer based system. Like, and then of course the other one is what you can really say is, so the information retrieval environment, a database is a collection of information that is organized and searchable and updatable also in the context of one or more specific applications. So in our context of ISAR, now, so database is nothing but it's a computer readable and information retrieval. It's a collection of information will be there on that. Some collected items will be there, information records will be there, organized and searchable. It is well organized. All the records are organized well in the database, and they are searchable and they are updatable also. You can update them, you can search them, you can retrieve them. They are organized in such a way that computer can really search and give you that. So electronic databases hold a key to improving information accessibility. When you really want to access information, I think these digital resources are really going to help you a lot. And for easy retrieval and all those things, now these databases are really been used, and in the earlier what you have in the print mode have been now converted into either CD-ROM databases or going into the online databases. Like, I think that's what is happening. So then the next important aspect is there are different types of databases are there. Database is an electronic database, when I really call electronic. There it contains a set of a good number of records or items are there, the computer readable, and it is again really been what you can really say is it is a computer searchable, and you can really retrieve from it, can update it also. These are some of the features of the database. Like, so there are 5 types of database are there. The first database, what you call it as reference database. At some point we have already covered this. Okay, document database, data, then database, something like that. And then one more, I think, reference bibliographic databases, then factual databases, and then document reference database. I think we have studied at some point. Like, I will again come back to that. So here what they really want to say that the databases can be of 5 kinds. One is a reference database. It's a database contains only references to the documents only, no full text. It can be references and also abstracts. Like, that's called exactly, is equal to bibliographic database. Means it will have only bibliographic reference of documents followed by maybe sometimes the abstracts also. The next one is full text database. This database contains full text of the documents. Okay, both the reference will be there, full text also will be there in this. Then of course directory type of documents, like something like a telephone directory. I think it's a directory kind of database. Okay, only the kind of list of the people, their addresses or something like that. Okay, then factual and numeric database, like census database. Okay, only the facts will be there, figures will be there. Then pictorial database with pictures. pictures, etc., and another database. These are all like slightly detailed like. So now the bibliographic and numeric databases, they have revolutionized the way information is now handled. Like anyway, now what really happened in this? All these databases will really help us. Number one, they reduce the time factor either for searching, retrieving, or for creating the database. Also, it won't take much time. When you really want to create a file or create a document, I think it's very easy. Okay, that's what number one. Then of course, when you are searching for information from them also, the response also is very fast. So searching is easy, and you can really maintain it as a current, means updating current information, like not old information. Anytime you can update it, updation is possible. Then time taken is very easy to produce, and then the time fast you can produce. Searching is also easy, and of course these kind of things are really going to really help us. So now in the course of time, what really happened, how the flow of information from print to database production has really been changed is, I think you have this in 236 page. Now the information producer or generator, maybe an author, something, a publisher, whatever it may be, or a researcher, analyst, or compiler, or reporter, they really produce a particular document. It goes in the form of a journal article, journals, books, reports, dissertation, thesis, conference papers, something. It goes on like that. From there, it will be really, of course, once the book is really been coming as a journal or a book, etc., etc., we, the librarians and other people, we also individuals, we acquire them, we procure them and select, and that will really further what happens. It can be really also used by the librarians in preparing abstracts, publication, index, something like that. So this information production, what is really been prepared, it will really go into these producers and database vendors. They really take it, they really enter the data and all those things, the data validation, editing, etc., and they bring out a electronic database will be really converted. Either you really bring out a book form, or you can really bring out in the electronic form also. Sometimes what happens, it has really come up in the beginning as a print book form. That print book form also can come as an electronic data. You can convert, digitize and convert it something there. So in electronic databases, the database can be offline CD-ROM databases. The databases can be, what you can say, online also. And within the offline databases, there can be CD-ROM databases. There can be disk or diskettes. Earlier, you used to 4/4 inch diskette used to be there. Okay, so in the that kind of things will be there, like CD-ROM. Then of course on magnetic tapes also used to be there. In the past, a lot of information was really preserved only in the tapes. Like on the tape the data was, magnetic tapes used to be there. Magnetic tapes, on the tapes the data was used to be real there. So then of course in the CD-ROM databases, of course they are physically with you, available with you, and what you can really also do is multiple CD-ROMs also can be integrated and in network mode, and you can really also access using a jukebox. Normally we call this a jukebox. So discuss, etc. This is how the initially author or somebody else, the researcher will really bring out a particular document. The document will get printed in a journal or a book, a report, or thesis, etc., etc. Then that will really further, it will really go into indexing, abstract and index of that will be really prepared, etc. Our libraries will really procure it. Of course, the same thing can be also converted straight away into, people can really now prepare electronic document instead of going to print media, or once they can go to print, and from print also they can really come back to electronic media. Like this is what normally happens as far as the what is the flow of information, how it is really going from traditional print to digital. Like now online services means the online information service vendors, publishers, etc., and through online vendors, now user can get his required information from the online databases in an interactive and conversation mode, sitting on a computer. I can sit on my computer, I will really search and find information from a particular database. Remotely it is available elsewhere. We don't know where it is really located. We don't know. But on computer, when I really come using internet, I can really go to the particular database site and I can talk to them. I've been talking, means not exactly oral talking. I'm talking, I can search with them and they will really respond back to me, and I really get information. Like so, this is what exactly we say interactive way. Interactive means I am interacting with the the computer server of that particular the database. Like that, from there my computer is talking to their computer server, and from there the computer server is again answering back from their server. It is really giving me the information back to me. So this is what interactive mode and conversational mode is really possible. There are 3 generations of the online services. First one, initially there used to be in a distant place, somewhere else, we don't know, and the host computer database used to be there, host server used to be there. I am here in the computer, I really make some kind of, I will type something, it will really respond something. That's what exactly the first kind of generation computers. Now that is called character based. I really ask something, I initially type some word, that will really respond, that host server. Then second generation is graphic based, pictures like, icons, etc. I touch that, it will really, instead of typing that, icons will be there. Now the third and the latest kind of generation is what you can really say is agent based or the client based, like okay, I'm a client and the actual original server where the database is there is a server. I'm a client, he's a server, he's going to give me that. I'm a client, I will really ask my question, then I put the question, and the question will be converted from my particular end into their particular server. Their server will really convert and translate into their language, and then their understandable language, and then it will really go to the database and search the information against my requirement, and then get back to me and give to me. This is a kind of conversation goes between a client, I'm a client using it on my computer, and the other one is a server. I think that is a server database elsewhere it is located, and we are getting the information like. So this is what third. So first one is only typing. That is what you can feel first generation, host based. There is a host, I am here, you just type and it will. Then there is icons, so the graphics like. That's what exactly you can really call it as graphic based like then of course the third one is this one, like that is what third generation is agent or client based information, like okay. This is what they way. There are so many major online database vendors are there. Probably the first most database vendor, online vendor, is Dialog. Dialog was supposed to be the first of its nature. Okay, Dialog database vendor was the first online database vendor. Dialog Information Services Incorporation of USA. Then of course Bibliographic Retrieval Services, BRS, is IRS, Blaze also British Library Automated Information Services like Blaze. Then Infoline, Datastar, OCLC, STN. Okay, there are so many database vendors are there, online vendors. Then coming back to the CD-ROM databases, online is Dialog supposed to be the first. Dialog, SDC, STN, okay, then Silver, so like that. But coming back to CD-ROM databases, probably Silver Platter company, Silver Platter data vendor is supposed to be the first database, first CD-ROM, database creator like. Silver Platter like, okay. The compact disk read-only memory, it has 12 centimeters in diameter and 1.2 mm thickness. That's just now you have seen so 12 centimeters diameter, 1.2 mm thickness will be there, and it's a optical technology based data will be there. Optical technology, laser technology we use now to make writing and reading. So computer optical technology. So CD-ROMs normally 660 MB capacity will be there in that. Now after CD-ROMs, now we got the DVDs. They are normally 4.5 GB or 4.7 GB capacity will be there. 6 times more than one, the CD-ROMs like, okay. But earlier we used to have 1.44 MB floppy disk used to be there. Okay, 1.44 MB floppy disk. From there we have really gone to 4.5 GB capacity of the CD-ROM. From there we have really gone to I think 660 MB, like that. A lot of developments have really come in these. So CD-ROMs, I think normally they can store up to about 250,000 pages of data can be stored on one single CD-ROM. Okay, DVDs there naturally will really its capacity is much more than, I think, at least 6 times more than what it is. Okay, 6 times or 10 times more than the DVD, etc. like, okay. So this is what as far as CD-ROMs are concerned. Now what is the advantage of CD-ROMs like? Now once if you store information on CD, so the storing of information is through burning the CD. Normally we call it, you will burn CD means not really putting on fire. So CD will you are recording the data on the CD. That's called bits and dots, etc. That's pixels. That's one. So it is a permanent storage data. Anything that is kept in CD-ROM, it is permanent, not erasable, not deletable. Okay, you can't change it. You cannot delete also. You break it, it will go. That's all. Otherwise, you can't really change it like. So then portability, you can take from here to some other place. I will put in my home, I will take my office, I will something like that. No, I will give somebody. It's a low cost production of document, very cheap when compared to book. CD production is very, very cheap. I think I don't know how much CD may cost.
25 rupees.
5 to 10 rupees.
25 rupees.
25 rupees. Okay. So initially it was I think $1 or more than that. Now it has come to very cheap, damn cheap. Okay. Now I think the CDs you are not getting in the market, only DVD you get it if you really want it. Okay, DVDs and pen drives are available, and no floppy disks and no CDs also these days. I think technology is changing, because when the advanced high capacity, storing, devices have come, the low capacity devices have gone out. They fade out like, okay. So permanent data will be there. It is durable. It won't really change. It will last for maybe, I think, a good number of years. Maybe they say 100 years, but we don't know. They also will get spoiled of some time. Portability you can take. It's a low cost, unlimited use. I think this till the whole data you can really keep on adding. I think 100 books you can keep in one CD, like that. Okay. So if it is DVD, more number of things can be really kept. Unlimited use. Data production is there. Data is protected now. Nobody can change and nobody can really erase it. Like so, if it is a network is already. Some CDs you can put at one place, so you can come and make them as a network, and you call them as a jukebox normally. So you can also have a network of all CDs and you can access from there also. So multimedia is available in there because it is a digital form. You can both sound, animation, text, graphics, pictures, everything can always be integrated into the kind of digital document that can be stored in the DVD or that can be stored in your CD-ROM. Okay, so that's all. These are all the advantages. Very cheap, very durable, portable, and permanent. And there are so many things are there, isn't it? So a disadvantage is that initial price of the CD-ROM database, not CD-ROM. The database are kept in CD-ROM, no? So the CD-ROM database are really going to be costly initially. And then, of course, the currency of CD product is delayed because now the CD is a physical kept. Now CD, when you really revise it, may take some time. If it is online available, I think today itself 120 times you can really change it, revise it. Access is limited to one person per CD inside. So one CD is there, one can only use it, like not many. If it is in a local network or this thing, many can also use it. That's the thing. Hardware, software compatibility and interchangeability still is a problem because the computer makers are different, operating systems are different. In that case, sometimes the compatibility, okay, interoperability, what normally call with all the systems and all the makes is going to be some difficult. And searching a CD is somewhat slow when compared to online searches. Like these are some of the things are there as far as CD-ROMs are really concerned. So the most important aspect is that it can really accommodate multimedia. Now it has really been supporting all kinds of operating systems. There's really a lot of things are changing because when the books were really been published in those days and now today, there's a lot of change has really come. So now we will really make a comparison of online and CD-ROM databases. And first is online database. It is basically an access technology. So the server is somewhere else. You are simply going and then asking them, they are really giving you information. You are getting only information. Physically, like this CD, you don't have in your hand, isn't it? You don't have anything in your hand here. So this is physically book is with me. Physically, this CD is with me. No, nothing is physically seen to you. Everything is virtual. Somewhere it is there in the database server, and from there you are really accessing. That's what basically it is access technology. You are accessing. You are not purchasing it. You are getting the access to the digital resources if it is online. Okay. If it is CD-ROM database, you are purchased. You can keep with you. But this is not keep with you. When you are searching, it is getting to you. That's all. Only access is provided. So CD-ROM databases, it's a storage technology. You are storing a huge amount of information and keeping with you physically. And then the online is they share the databases. Okay. So database are there in the server, you are sharing. They are giving to you or you are taking it. Like I told you, access only. Na? That's what exactly. Here it is optical storage media. So that is virtual. There with them only, you don't know. Now here it is optical media. This is the CDs and DVDs are called optical storage media. Okay. The third one is now they share the databases. Now okay. Now the pay as you use. So how much you are using, for that much you have to pay for that. If it is CD, once for all you are purchasing, it is there for you. Any number of times you can use. Nobody can question. Once you pay, it is with you. You can use it like. That's what exactly. Okay. Then more you use, more you pay. Naturally, if it is online service, you are staying online for longer time, you naturally you have to pay more. But of course, that is also now changed because you are also only subscribing, getting the license. Any number of times you can really use it like that's it. Now the earlier it was like that because dialogue and all those things were there, SDC, Orbit all there. I think you are on the online. Online was very costly. So if you stay online for longer time, naturally you have to pay more time. That was the situation. Right? Okay, that's what we said. Pay as you use. If you can use for the longer hour, pay more amount. This is a prepaid searching. Yeah, in the beginning. Now it is what happened. Prepaid licensing is there, not prepaid searching. You pay in advance and then take the access rights. Access license is given to you. Okay. Now, if it is you have already paid once the price for the CD and it is with you. You can use any number of times, anytime you really want. Nobody can really bother for that. Okay, online was not like that. Multiple file searching is possible from the online database. Here it is only single file only you can search here, not multiple files. So search, get and pay, get and search. Then you search for information and pay for that. And here it is, you pay first and get the search. So these are all some of the the differences as far as your CD-ROM and online databases. We also call them as CD-ROM database are offline. Online database are online. Okay, so lot many databases, the chemical abstracts, biological abstracts, current contents, like that, they all have come into the online databases. So chemical abstracts, I think this abstract publication, the best publication in chemistry subject field. Then biological abstracts also in the field of biology. It's a quarterly operation is there. Current contents, I think this used to come from Institute for Scientific Information in Philadelphia. Eugene Garfield, I think that person has really been started that ISI, and for one of the important publications. Science and Technology Reference Plus. Adonis is a full text medical database. These chemical abstracts, biological abstracts, okay, current these current contents, all these are bibliographic databases only. They contain bibliographic details and also abstract, nothing beyond that. So the current contents also do not contain abstract also, only bibliographic details, like so like that this. But Adonis is a full text database in the medical field. And so like that, there are quite a good number of databases are now coming up in both online and offline. When I say online, means using internet, you are really going to access them using internet and browser and computer. And offline means maybe in CD-ROM or floppy disk or diskette, etc., or DVDs, etc. Like. Okay, electronic journals. Now, this is the one normally people will be asking you, what is electronic journal? I think you should really know. Electronic journal is a kind of online journal or offline. Normally online journal only. It's in digital form. It's a paperless journal. Online journals, virtual journals, network. There are many names are there. Okay. Now it is as good as your own print journal only, but it is available in digital form. It is that's what exactly electronic form. So that's what you really call on electronic journals. Online means only available through internet. Now even a journal can also be there in a CD or DVD. That could be also electronic journal only. Electronic journal can be online and it can be offline also. Okay, that is possible. Okay, there are ASCII code, scanned, structural, formats are there. Then CD-ROM publishers, as I told you, Silver Platter was supposed to be the first one. Then Dialog on diskettes, Dialog is another CD-ROM. But Dialog was supposed to be the first online vendor publisher like this. Then when you are purchasing, you have to see so many things. But now these days it has really been out of context because things have really changed. Okay. Then what is left out? So when you are evaluating a criteria of CD-ROM or online services, what things you response time, when you go and search for information, how much time is it taking? And is there anything when you are searching, your process of searching information is interrupted, or any problems are coming? It will really, does it really support you the Boolean logic based and or not? Boolean operators for searching is there, truncated searching is there, multiple word searching is there. I think these are all facilities do they have in that. You really try to, can you also search and find and retrieve and print your documents Okay, is it user friendly? Whether the screen is giving you some kind of guiding you or prompting you to get some good query, etc. Okay, how good is the computer support is there with you, etc. These are all some of the things you can really look into. Then there are information retrieval from online systems, models, and protocols. So conventional model is there. Then other one is a client server model. Client server model is going to be the latest one. There are two models. Conventional model means there will be a data. Then retrieval software is there. User interface. Some data is there in some database, and then user is there. User will really ask the computer interface. Then you will really get the data from the host computer. That's what normally a conventional method. You have a PC computer sitting on here. You really make a query, and it will go to the database server site, and from there it will really take the question, translate that in, and they get the answer required to that, give back to you when you are here in the computer line. So then client server is one very important aspect. Is there will be a dialogue between the you as a client and the server elsewhere is there. There's a kind of interaction is going on. That's what normally client and server. I am a client, server database located elsewhere. This is a new method or new mechanism of that. Then equal to that, you have CONET you have studied, no? Just now in the morning, CONET we have studied in the beginning. It's a common command language. Like similarly, Z39.50 is also a protocol of the American, NISO. NISO is a National Institute for, National Institute for Information Standards Organization of America. Now they have also created one kind of a protocol to use a kind of common, the search query. But you can really put a search query onto a particular database, it automatically converts into the database style of the terminology, and it will really get you back answers like that's what exactly we can really say. Now internet services, I think internet is a mix of so many database, so many websites and all those things. Their data can be really, you can get journals, you can get reports, you can, a lot of information can be really obtained from the internet. And what you can say, it provides access to electronic books, journals, reference works, government publications, statistical data, directories, indexes, university calendars, documents, maps, graphs, pictures, multimedia, library catalog. Everything can be really, you can really get from the internet. Like that's what exactly internet services. And you have got internet based other services also. Okay, this is what precisely as far as your the second unit what I said was online and CD-ROM databases. This is what we have really finished these 2 units for today. Now any questions from your side you can ask me, because the only thing is, since I have to cover a lot of things, I was slightly rushing. So much of data information is there, we have to cover in 2 hours. So towards time is not sufficient, but we have to cover. So that's what I know. I'm just slightly running quickly, fast, in order to see that at least I should give you some basic, information about each and every topic. And that's an idea. Please, now, if you have any questions, anything that you did not understand, you can ask me now. Any questions? If you cannot ask, you put me in the chat box also. No problem. There are, excluding me, there are 17 members. Okay. Sunday is a free day for all. But I don't know why feel like attending the class. Sitting at your home, you can attend, isn't it? You have a mobile, you can attend. You don't need to have a computer also. Yes, next, any questions? Viraswamy. Archana. Raja Rajeshwari. From bro, who is there online? It's a Kiran or Raja Reddy? Raja Gaud. Rahul. Raghuveer, Sadula, Rajita, Shimohan. Anybody have any questions? No questions.
Sir.
నా మాటలు నిలబడతా మీకు ఎవరికైనా?
Yes, sir.
Any questions from your side?
No, sir, it is clear.
No question.
It's all clear, sir.
Clear.
We understood the class very well, sir.
Very good. ఎవరికైనా ఏమన్నా questions ఉంటే I will give another 2-3 minutes time. You can ask me. Otherwise, we will conclude for this day. Probably I may be getting one more class, I think, maybe in the next week.
Yes,
And
sir,
next
next
week
Saturday.
Next Saturday, you are right. So there will be 3 units left out on that day. So same is the speed. I think we have to go again rushing. But I will give you the
sir,
gist of
it's
it.
not too fast.
Pardon, madam?
It's not too fast, sir.
Okay. That's good. Very good.
We are able to catch you, sir.
Nice. So you are also running along with me. So we are all running. Teacher is also running and the students are also running.
Yes, sir.
Good. So we are in a race now.
Life is a race, we must run.
Good. Very nice. So then we will meet next week and we will try to finish up this course, this paper.
Okay, sir. Thank you, sir, for your
Thank you.
explanation, sir.
Thank you. Okay.
Thank you, sir.
Thank
Sir.
you.
Thank you so
Yeah.
much.
Yeah, any question? Anybody has any question?
సార్ ఇప్పుడు అసైన్మెంట్ లో లాంగ్ క్వశ్చన్స్ ఉన్నాయి కదా, షార్ట్ ఆన్సర్ వచ్చినాయి, ఎట్లా రాయాలి సార్ అది ఇన్ఫర్మేషన్?
ఇప్పుడు మీరే చెప్తున్నారు కదా, కొన్ని లాంగ్ క్వశ్చన్స్ అన్నారు, కొన్ని షార్ట్ క్వశ్చన్స్ అన్నారు. లాంగ్ క్వశ్చన్స్ కి లాంగ్ ఆన్సర్, షార్ట్ క్వశ్చన్స్ కి షార్ట్ ఆన్సర్, అంతే కదా?
కాదు సార్, షార్ట్ క్వశ్చన్స్ కూడా లాంగ్ ఆన్సర్ వచ్చినాయి సార్. అది
అవునమ్మా, కొంచెం డీటెయిల్ రాయండి, ఇంకొంచెం డీటెయిల్ రాయండి. ఏమంటే ఇప్పుడు మనం నార్మల్ గా షార్ట్ క్వశ్చన్ అంటేనేమో మేబీ 1 పారాగ్రాఫ్ అట్లా రాస్తాం కదా, 1-2 పారాగ్రాఫ్స్. ఇది కొంచెం ఇంకా దాన్ని ఎక్స్పాండ్ చేయొచ్చు. సపోజ్ ఒక క్వశ్చన్ చెప్పండి నాకు, నేను చెప్తాను సార్. యూ ఆస్క్ మీ వన్ క్వశ్చన్ విచ్ ఇస్ షార్ట్ నోట్ క్వశ్చన్ బట్ హస్ కమ్.
ఆటోమేటిక్ ఇండెక్సింగ్.
ఏమా
ఆటోమేటిక్ ఇండెక్సింగ్ సార్.
యా, ఆటోమేటిక్ ఇండెక్సింగ్ ఈజ్ ఎ లాంగ్ క్వశ్చన్ నార్మల్ గా. ఇట్ ఆల్సో కెన్ బి ఎ షార్ట్ క్వశ్చన్. ఇప్పుడు ఎగ్జామినర్ కెన్ ఆల్సో. ఆటోమేటిక్ ఇండెక్సింగ్ అంటే ఏమిటి? ఇట్స్ ఎ మెకానికల్ వే ఆఫ్ giving the index entries by the computer from the digital resource or digital document is really going to be called as automatic indexing. When you really want to say, normal traditional indexing is done by the human being after content analysis, identifying the subject and then giving the keywords, etc. The same thing is really done by the computer. Like there are, I think, keyword indexes are the basic thing, and HP Luhan was there and others, etc. were there. They really prepared it. Now in this, normally what happens, you can, there's a lot of studies there in that. Okay, now I have given you one example also, one HP Luhan, how he has really prepared that. I gave an example also. The example was now giving the injecting the the female hormones into the ailing male patients, and then in order to seeing also that male person could not get the female traits and characters. So this these hormones, female hormones, if you really inject to the ailing male patient, he will really recover fast and he won't get heart attack. So this kind of studies were also really in the beginning page he has really done. When you really put all these particular one page document into the computer, computers have really been made analysis of all those things. It has identified the keywords from that, and then all the keywords and the frequency count was really been made, and this word, this meant, this word, this meant, etc. were there, and after all these things, it has really given a kind of index entry, etc. Okay, that's what exactly the HP Luhan's keyword indexing or the kind of automatic indexing. It's most exactly how it really goes on is, now it's a frequency count of the the subject keywords occurring. How frequently it occurred is going to be the keyword or the index term that is really given to that. Even if a human being also really going to give a keywords, more or less the automatic indexer keywords and also the humanly prepared index words are going to be same. I think how much you can write? You can write at least for 3-4 pages easily. You can write, correct now? So it's a possible. It's possible. Any other question you have, which is start notes question, but it has come as a long question. Then if you are really too good, what you can really say is, if it is a manual, the indexing, how it is done. It is an automatic indexing, how it is done. What is that benefit? It's a manual indexing. How effective it is. How effective this is. The benefit of that. Benefit of this. Drawbacks in this. Drawbacks in this. Oh, there's a lot many things are there. Just think. Just think. You will get lot many things in your mind. Isn't it? So any other question, short question, which is really coming up as a long question? Please tell me. I will answer it now. Don't worry. Others can also ask me something else. No problem. No problem. Others, any others, anybody is having any other question, please.
ISBD, sir.
ISBD. Oh my goodness. It was there in the initial topic, isn't it? ISBD is in International Standard Bibliographic Description, isn't it?
Yes, sir. Yes, sir.
Yes, you are right. So International Standard Bibliographic Description, it is really been given by whom? Who has really brought out this? Who brought out this? Please tell me. What is ISBD? ISBD is, it's an international standard for describing the documents. In your catalog system, there are, in every catalog entry, there are two parts are there. The top one is heading, down that is description, body. Header, heading, and body. The body description is based on ISBD. ISBD has got 8 areas, 8 sections are there. It has 8 areas are there. Title and statement responsibility. Okay. Then of course your edition statement. Then of course that what you can really say, material and specific details area. Then of course your publisher, distributor, etc., imprint area is there. Then followed by that the physical description is there, like how many volumes, how many pages, etc. will be there. Then the note section is there. Followed by that the physical description followed by the we have series statement is there. Then notes section is there. I think the last one is what exactly? I think you have got, what is the last section? So there are 8 areas are there, 8 areas of description in your ISBD. Okay. And it uses a specific punctuation mark, isn't it? Like, between, every area out of these 8 areas, between each and every area. Now, you have to really use the punctuation mark in order to show the indication that the area is over and the fresh area is being started, like, okay. So that is what full stop space dash space is the indication. What that you have done in your BLSC in your cataloging, that it's not at all a big issue. It's not at all a big issue, isn't it? There are 8 areas of description are there.
Yes, sir. In this coming, కాకపోతే ఏంటంటే ఇది షార్ట్ క్వశ్చన్లు అడిగింది సార్, అందుకని
అడగనియండి, మనకేముంది. ఐఎస్బిడి అడగచ్చు, ఐఎస్బిడి జి అడగచ్చు, ఐఎస్బిడి ఎం అడగచ్చు, ఐఎస్బిడి ఎస్ అడగచ్చు. ఎస్ ఫర్ సీరియల్స్, ఎం ఫర్ మోనోగ్రాఫ్స్ ఆర్ బుక్స్, జి ఫర్ జనరల్ ఐఎస్బిడి. Okay, so like that people can ask, what you can really say is it's a standard, okay, that was really developed by ISBDs were developed by IFLA, isn't it? Yes or no?
Sir, ISBD NBM అని అడిగారు సార్. ISBD NBM ఫ్రేమ్వర్క్.
NP అంటే నాన్ ప్రింట్ మీడియం, నాన్ బుక్ మెటీరియల్.
నాన్ బుక్ మెటీరియల్.
Non-book material also called as non-print material. NPM, NBM, same. Okay.
Okay.
So ISBDs were brought out by IFLA. IFLA is International Federation of Library Association Institutions. So it has really brought out a standard called ISBD. Okay, ISBD is meant for only how to describe the details of the document in the body of your catalog entry. Headings are not part of this. Headings are already been given by another standard was already there. Okay, so headings are not there. ICCP principles, International Conference on Catalog Principles, has really given you the headings, how to really make it. The first part heading. The second part is body, the description. In the description, there are 8 areas are there, isn't it? So between each and every area, you have to use a punctuation of full stop, space, dash, space. So between again within the area, there can be sub areas also there. You are trying to indicate them by using another some kind of punctuation mark. So title, then parallel symbol, equal symbol, then other the same book in other language title, like say Vikram Orvasi is in Sanskrit, the king and his nymph is the translation of that, the in English language. So Vikram Orvasi equal to the king and his nymph, oblique by something like this is a book by whom, I think the author name. So like that, you have to Kalidasa. Okay, you have to really Kalidasa is the author for that. So like that, full stop, space, dash, space. Then addition, it's like there is no addition. Then you go on to the next area. Like that, you have to really go between each and every area, and between each and every within the area, sub areas, we have got a clear punctuation marks are there in order to understand each and every piece of information. This is the international standard being also used in AACR2, this one, that one, etc., etc. That's all. Okay, go ahead. No problem. So it's okay.
Okay, sir.
Okay, sir.
So for today, we will leave the session now, and we will meet in the next session, maybe the next week. Right?
Okay, sir. Thank you, sir.
Thank you.
Okay, sir. Thank you, sir.
Thank you. Thank you.